This video will cover the concept of linear regression. It is an advanced version of the correlation analysis. The difference between the correlation analysis and the regression analysis is that the correlation works with finding the degree of relationship between two variables, while the regression analysis works with finding the amount of effect of independent variable on dependent variable. For example, if someone is saying that BMI and age are correlated with each other, it means we are expecting that with the increase of age, the BMI will also increase. But how much the BMI will increase with the increase of age? For example, someone may ask that if the age is increasing with the if the BMI is increasing with the age, so if for example today I am 20-year old, so next year if I will be 21 years, so what will be my BMI when I will become the 21-year? And this is a question which is answered by the regression analysis. So correlation analysis works with finding the increment or decrement and the strength of correlation between two variables, while regression analysis also determine the amount of that effect, that how much one variable changes because of the another variable. This terms comes in the regression analysis. There are steps as we conducted in the correlation analysis. Also, like the first thing is to find out the whether the variable are linear or not. Just keep in mind, we are working with two continuous variable or two quantitative variable at this moment. So first of all, we have to draw scatter plot or find the value of correlation between two variable to find out if the two continuous variable are linearly associated or not. If they are found to be linearly associated or they have some sort of a correlation, so we will work out with certain steps which are defined in a slide also. Second step is to find out the relationship between two variables. For example, this is the equation for the linear regression, that y is equal to b naught plus b1x, where y is equal to dependent variable, b naught is the constant, and the b1 is the coefficient of the regression coefficient, and x is the independent variable. So for example, if we are working with finding out the correlation between the, say, let's take the example of the employment rate with a month of lockdown. Months of lockdown is our independent variable, employment rate is our dependent variable. And I will see, say, for example, the employment rate is, let's suppose, 5%, and it decreases with the 0.2% with the months of lockdown. Another example we want to take is the, say, inflation rate, which is 3%, for example, and with lockdown it increased to 0.5%. So in these two equations, in our first example, inflation rate is our independent variable and employment rate is our dependent variable, which are y's. The b naught and b1, the b naught are 3% in our equation 1 and 5% in our equation 2, while the b1 are 0.5% in the equation 1 and 0.2% in equation 2, while the months of lockdown are our independent variable, which are x here. So there is a reason of using these two example. Like we have kept that independent variable is the same, which are month of lockdown, while inflation rate is our dependent variable in our first example, employment rate is the dependent variable in our another example. I'm going to explain this B node and B1 in next slide. B naught and B1, as discussed before, these are the regression coefficients. So in our first example, our major concern starts with the B1 usually. Like in our first example, inflation rate is equal to 3% plus 0.5%. And the interpretation of B1 are with 1 unit increase in independent variable, the dependent variable increases up to B1 unit. Why increase? Because the regression equation contains the plus sign in it. And when there is negative sign in the B1, we will say with 1 unit increase in independent variable, the dependent variable decreases up to B1 unit. So our in our first example, when we had that 3% plus 0.5%, 3% is the B naught, 0.5% is the B1, and it is a positive quantity. We will say with the increase of the month of lockdown, the inflation rate increase up to 0.5%. And in our second example of the employment rate, with the when we have the example of the month of lockdown inflation rate, there is a negative sign. We will say that with the increase of the months of lockdown, the uh, inflation rate decrease up to 0.2%. Whereas the B1, B naught is the average value dependent variable, but it is not the simple average, like dividing all the values and from the sample size. It is the average value when the effect of independent variable is zero, removed, or mitigated, or let's say it is not considered. So we will say each month the employment rate increase up to 5%, but as we increase the month of lockdown, each month increase in the each month increase in the lockdown, the employment rate decreased to 0.2%. This is interpretation for regression coefficient. Then the next question arises if the model which we have built using the regression equation is good fitted or not. So this is determined by the coefficient of determination, which is nothing but the square of the correlation we discussed in our last video. That this is a quantity which measures the proportion of variability explained by the fitted model. For example, let's take the inflation rate. In our data, the inflation rate has its own variance. So if we say that variation is 100%, so if and let's suppose the R square for the regression equation 1 comes out to be 0.89, we will say there is 89, the regression model which is constructed based on the month of lockdown. So 89% of the variation in inflation rate, our dependent variable in our first equation, is explained by the months of lockdown. The remaining 11, this is not a part of interpretation, but we are saying that the remaining 11% is with this error quantity. The remaining 11% is not explained by the month of lockdown. There are other factors which is actually increasing the inflation rate. So the remaining 11% is based on some error. There may be some other variable which are affecting, but this is not explained by this regression model. This regression model only explains the 89% of the variation in the inflation rate as overall. So before proceeding, our next stage is to check the model validity. And the amount of effect and the tested statistics which is given in the SPSS output. And the last step is to predict if it's right, which is the next objective of the regression analysis which we use for the prediction. In our HSP2 data, we worked out on finding the correlation between a reading and writing score, and we found that the writing score increases with the reading score. So This time we are going to work out, okay, if the writing score is increasing with the reading score, so what will be the reading, what will be the writing score with the increases or with the 1 unit increase of the reading score. For this live video, we are finding the answer of these questions. Like first of all, finding the correlation coefficient and interpret the output. We are going to estimate the regression model and interpret the coefficient using the reading and writing score as independent variable respectively. We are going to test the significance of regression coefficient and interpret the coefficient determination to check if the constructed model is good fitted or not. And from the predicted model, we will also predict the writing score for a student who has the reading score of 95. So in the SPSS, we will go to analyze regression and linear. And then in the dependent variable, we will put the writing score and the independent variable reading score. And we will, at this moment, we will simply press OK because the answer of all the question given here are present in the table, which is which are displayed in the SPSS output sheet. Like for example, finding the correlation coefficient, this is the R, which is 0.597, which is the value of the correlation we discussed in our previous lecture also, and we can interpret it also. Second thing is that R square, which is the coefficient determination, it is the answer here, and R square is actually give us the value for model fitting. The ANOVA table is not that much worthwhile at this moment. Our major concern is with the coefficient table, which contains the beta naught and beta 1 value. The beta naught value here is 23.959 and B1 value is 0.552, and the significance of the B1, B naught and B1 are given in the last column. So here are the answer, like interpretation of correlation is the same as the correlation value of 0.597 indicates that there was a moderate but positive correlation between two scores. With the increase of the writing score, the reading is with the increase of the reading score, the reading writing score is also increasing. Regression equation is based on these quantity like 23.959 plus 0.552 reading score, and R square is 0.356, and we have mentioned the p values of both the coefficient in the parenthesis. The interpretation of B1 is now that with the increase of the reading score, one score increase of reading score, the writing score increase up to 0.552 score, and the B naught is 23.959, which means that the average writing score of students are 23.959, provided that if effect of reading score are not considered or mitigated or removed. In the end, R square, which is which comes out to be 0.356, indicating that 35.6% of the total variation is explained by the writing score. So the model is not that much good fitted for to the data. The last option is to predict the writing score when the reading score of a student is 95. We will put this 95 in the regression model and we obtain the value while using the mathematical operations. The writing score is 76.21. It implies that when the reading score is 95, the student who gets the reading score 95 will have the writing score is 76.21. This is for now. See you.